Hi friends, welcome to this video. So this is KCET 2018. Here in this video, I am going to discuss the question from 11 to question number 15. The question number 1 to 5 and the questions 5 to 10 have been discussed in two videos. Video number 1 and this is video number 2. Whereas now I am shooting the video 3 which continues those questions, right? So the question number 11, they have asked the dead burnt plaster is option A, B, C, D. They have given, right? So before ticking the correct option, let us discuss this thing. So gypsum is what? Calcium sulfate, CaSO4, calcium sulfate into 2H2O. We call it as what? Gypsum, right? So this gypsum, if I heat it, the same gypsum, if I heat it, I'll get CaSO4 into half H2O, right? Half H2O. This we call it as what? This we call it as plaster of Paris. POP we call it as plaster of Paris, which is used for designing the houses or constructing a models. Those things we use this plaster of Paris. And in the accident thing, they will apply this only plaster of Paris. The doctor will put on the broken arm, right? So this is about pop. So here we had gypsum. When I heat gypsum, it was 2H2O. Now it becomes half H2O. Further, if I heat around more than 393 Kelvin, if I heat more than that, this CaSO4 into half H2O was there, right? I will get CaSO4. Anhydrous CaSO4 will get. Anhydrous means what? Absence of water. Absence of water. We call it as anhydrous CaSO4. This is nothing but the dead burnt plaster. This is nothing but the dead burnt plaster. So calcium sulfate. Option A is the correct option. I hope you got it. Gypsum, when we heat it, we'll get pop. What is pop? Plaster of Paris. When we again heat it, we will get this dead burnt plaster, right? So this was about question number 11. Coming to the question number 12. Identify the following compound which exhibits geometrical isomerism. So before looking into these options, let us see what is this geometrical isomerism. This geometrical isomerism will be exhibited by alkenes, right? It will be exhibited by alkenes. First point you have to remember. What kind of alkenes? Alkenes means C double bond C should be there, in which both atoms, see this carbon is the right here. If I have CH3 methyl group and here if I have hydrogen, or this carbon is having CH3 group and next to that if I have hydrogen, see, so carbon double bond is there, alkene, and this carbon is having CH3 group on above and this carbon is having CH3 group on above. So this we call it as both bulky groups, methyl groups, CH3 groups are on same side and both small atoms like hydrogen are on same side. So this we call it as cis alkene we call it as, and also it is also called as sometimes Z nomenclature, right? Similarly, if C double bond C is there, one bulky group, it can be methyl, ethyl, anything. Methyl group if I take and other methyl group are opposite, see. So this carbon methyl is here and this carbon attached to this methyl opposite side, and here hydrogen, both small atoms are opposite, then that is called as transalkene. Transalkene is also called as E-alkene, right? So this is the geometrical isomerism. Cis and trans are the geometrical isomerism. Z and E are the geometrical isomerism. But you may ask, sir, I have this molecule C double bond C, here I have CH3 group, here I have other than CH3 ethyl group, and here I have hydrogen, here I have deuterium. Whether it is cis or trans, I will tell that, see, this is also bulky group methyl, and this ethyl is also bulky group. Since both are on same side, so we use the nomenclature Z. Instead of using cis, we can use Z, right? If both were opposite, then we used to use E. And you may ask, sir, what about this? If I have double bond C, here I have CH3 group, again here I have CH3 group, right? And here I have CH3 group, CH3 group, and here I have hydrogen. Whether it is cis or trans, you will ask. I will tell we can't tell any cis or trans E or Z for this compound. Why? Because this carbon is attached to same methyl. Here also same methyl, here also same methyl. We can't do such a nomenclature. What kind of nomenclature? Nor cis and trans, nor E or Z. This is nomenclature we can't do. Whereas, so what is the condition? Carbon should be attached to two different groups. See here methyl is there, here hydrogen is there, here ethyl is there, here deuterium is there, here methyl is there, here hydrogen is there. Then only we can do that E and Z nomenclature. So they have asked, they have given these options A, B, C, D, and we have to tell that which among these A, B, C, D 4 options exhibits this geometrical isomerism, right? So from D we will go. So what is this? Isobutane. Ane means it is alkane, and we know that geometrical isomerism will be exhibited by only alkenes, not the alkane. So this won't exhibit. Butane. Ane means alkane. Alkane means it doesn't exhibit. And here we are left with option A and B. Option A is but 2-ene. Option B is but 1-ene. But means how many carbon? Let us draw the structure of A as well as B. A means how many carbon? But means 4 carbon. 1, 2, 3, 4. But 2-ene means 1, 2 numbering. If I do second position, double bond is there, and I have to balance the hydrogen. Here 1 hydrogen, right, and here 3 hydrogens, and here C double bond C, here 1 hydrogen, and here 3 hydrogen. So see, this can be written as like this: C double bond C, 1 hydrogen here, and 1 methyl group here, CS3. Similarly 1 hydrogen here and 1 hydrogen methyl group here. So both are same only. So it exhibits what? Now it is cis. If you want to write trans, this methyl will shift here and hydrogen will shift here, so that will be trans. So A will exhibit cis and trans isomerism, that is geometrical isomerism. What about B? But structure. Let us draw this B structure. So but 1-ene. But 1-ene means 4 carbon, here double bond, but 1-ene here. So here CH2, and here CH, here CH2, and here CH3, because carbon valency is what? 4. So here we can see that here double bond is there, but to this carbon same 2 hydrogens are attached, so it doesn't exhibit geometrical isomerism. Are you getting? Otherwise, if I want to draw the structure thoroughly, you can get to know that. See here. Yes, if I want draw the same structure like this, see, it can be drawn like this: C double bond C. This same carbon is there, right, attached to same 2 hydrogens, so it doesn't exhibit this geometrical isomerism. Here instead of writing CH, CH2, CH3, I can write it as ethyl, ET, right? So here this carbon is attached to same hydrogens, it doesn't exhibit any geometrical isomerism. So option A is the correct option. This is about question number 12. Now talking about question number 13. So 13 is during the fusion of organic compound with sodium metal. What they are doing? They are taking one organic compound and they are doing fusion with sodium metal. Nitrogen present in the organic compound is converted into. The nitrogen present in the organic compound is converted into, they have asked. So it means what? Organic compound contains what? Nitrogen. So we can take anything. So you are familiar with this kind of compound. Benzene ring attached to NH2. This is aniline, right? So this is the organic compound containing nitrogen. Or I can take other organic compound like benzene ring containing NO2 group. So this is what? Nitrobenzene, in which organic compound containing nitrogen. So any organic compound if I take, to that if I add sodium metal and fusion means nothing but we heat it thoroughly. We heat such a way that it become a very red hot, means there will be a glass tube like this. Glass tube will be there. To that we will add sodium metal here and we will add these organic compounds here, organic compound. Later on we will heat thoroughly so that this glass is there, right, that will become red hot, so that there will be fusion will be thorough. So this reaction we call it as fusion of organic compound with metal sodium. So any organic compound if I take, so we assume that I am taking only aniline, that is aniline means organic compound containing nitrogen. To that if I add sodium metal and if I heat it in a glass tube. That reaction we call it as fusion. It forms any compound. See, this carbon and hydrogen will be converted to carbon, and this nitrogen will be converted to N, right, and this metal will be there, right. So Na plus Cn minus, sodium cyanide will be formed. What it will form? Sodium cyanide. So whenever any organic compound, if you take nitrobenzene organic compound, to that if I add sodium metal and if I heat it in a glass tube, it forms what? Sodium cyanide. So there will be formation of sodium cyanide. That is option C. This we have studied in PUC first year. That is class 11th, in the chapter some basic principles and techniques of organic chemistry, right. There we will study about this reaction. So question number 13 is C. Talking about question number 14. See, the reagent X, we have to tell the reagent X in this reaction, right, used in the following reaction is, right. So X can be nickel, or it can be palladium carbon, it can be LiAlH4, or it can be sodium in liquid ammonia. We need to get this product, right. We have to tell that. So I will tell you. So this is what R C triple bond C R dash is there. Right. So to this, right, to this if I add this hydrogen, so here these are not 2H, this should be hydrogen. Here one hydrogen and here one hydrogen. Alright. So to this if I add hydrogen in presence of nickel catalyst, I won't get any alkene, I will get directly alkene. What kind of alkene? R will be there. Here triple bond was there. Now it becomes single bond here. Carbon R dash. Other things here 2 hydrogens will add, and here 2 hydrogens will add. We will get from alkyne. This is triple bond means alkyne. From alkyne we get only what? Alkane. When in presence of nickel catalyst. So, but here they have given, we need to get what? We need to get alkene here. Alkene. So this is not the suitable reagent. So lithium, the same, hydrogen in presence of hydrogen and in presence of option number C, LiAlH4, lithium aluminum hydride, if I add, it is not going to reduce, right. It is a good reducing agent for C double bond O group, right. Any carbonyl, chloride, right, those things, carboxylic acid, aldehyde, ketone, it will reduce that, but it is not going to reduce any alkyne. So this is the not suitable reagent. And talking about D means what? I have this alkyne, C triple bond C R dash. To that D option, what is there? Sodium in liquid ammonia. So sodium in liquid ammonia, right. Here what happens, we will get, see here, this alkyne is there, we will get alkene, no doubt. R C double bond C R dash. One hydrogen will add this side, other hydrogen will add this side. We will get what? Trans product we will get. We will get what? Trans product. But in the reaction they have given, see, this is what? They have got alkene, which is cis product. So from sodium in liquid ammonia we will get trans product. So this is also not the option. So correct option is B. So palladium in presence of carbon will get a cis alkene, whereas in sodium in liquid ammonia will get water? Trans alkene. So this you have studied in the chapter hydrocarbons of PUC first year. There you have to study. You have studied. And now the question comes, why in this we will get trans alkene, and why in presence of palladium carbon we will get cis alkene? That you have to do by yourself. If you won't get it, just comment in the comment section, so that I will help you with that, right. I will give the mechanism and explanation, then you will get to know. So this is about question number 14th. Option is B, or the second option, right. Coming to question number 15. So for this video it is the last question, which goes like this. Which of the following ions will cause hardness of water? So it is direct question. It is from the chapter hydrogen, which is of class 11th or PUC first year. PU first year, class 11th, right. So hardness of water will be determined only by two cations. One is Ca2+, other one is Mg2 plus. If in water either of calcium or either of magnesium, within these two ions, either calcium or magnesium, if any one is present in the water, that water will be what? Hard water. That water will be hard water. But within this hard water, there are temporary hard water and there is permanent hard water. Permanent hard water. Temporary hard water means it is based on, along with these cations, there will be anions which determine this temporary hard water. So here permanent hard water means along with those cations Ca2 plus Mg2 plus, there will be some anions which determine whether it is permanent hardness or not, right? So the hardness mainly depends upon these cations. So cation, calcium or magnesium. Here they have given the option calcium, so A is the correct option. Now your homework is, you have to tell in temporary hard water along with calcium or magnesium which anion will be present. That is the homework. And in permanent hard water, this is permanent hard water, you have to tell along with calcium and magnesium cation which anion is present. Which anion is present. That you will get it in the chapter hydrogen, where you will study about water, right? So this is about this video. If you like this video, give me a like button, share with your friends, it will be helpful for them, right? Subscribe the channel. Thank you.